Yeah, hello everyone. Good evening. I think I'm audible to all of you. Let me know in the chat, guys, if I'm audible. Yeah. All right. So thanks for joining, guys, and welcome to day 5 of our Computer Vision for Developer series. And today's discussion would be padding and stride inside CNN. Okay. So I think you remember, guys, yesterday I was talking about like how convolution works, how let's say filter works. Okay, I showed you the entire mathematical demo. Even I also showed you the visual representation of that. Okay, now two more. I think see some more topics are left. Like today we'll try to cover the paddings and stride, and the next class I'll try to cover the pooling layer. Okay, inside CNN. Then we'll try to move to the architecture part. Okay. Hmm. So this is very important session, guys, because here you will be learning one very important concept whenever you are designing your own CNN architecture. So this concept will help you a lot. Okay, so make sure, guys, you complete the session till the end, and if you have any doubts, so please let me know in the chat. So chat is open for all, so please try to put your question in the chat. I'll try to definitely pick up from there. So before starting, guys, please hit a like. All of you hit a like, and if you are new to my channel, guys, please try to subscribe, and let's try to hit 50k subscriber as soon as possible to my channel. Fine. So this is the playlist, guys. So we have already completed till day 4. You can see last session I was talking about the convolutional operations. So if you haven't checked that, just try to check the previous sessions, then you can continue without today's discussion. Okay. Yep. And all the resources are available in the GitHub. Okay, so GitHub link would be present in the description. From there you can check it out. So till day 4 I have updated all the resources. So let's continue, guys, today's discussion. So let's take a new notebook. So agenda for today. First thing I'll be talking about padding. Padding in CNN. Then the second things I'll be talking about strides in CNN. Okay, so these two topics I'll try to cover. So first of all, let's try to discuss about the padding. Okay, what is padding and why it is required? So I think you remember, guys, I think yesterday I was showing the convolution operations. Okay, so I think I have some animation. Let me show you. So see, that's how convolution happens. That means you are having your input image and you are having a filters. Okay, you are having a filters. We also call it as a kernel. We also call it as a feature extractor. So here you can see my input sizes, input image sizes 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That means 5 cross 5. The input size is 5 cross 5, and the filters we are using, the filter size is 3 cross 3. So after doing the convolution, the feature map I'm getting. Now what is the size of the feature map, guys? Tell me. So let's say my original image size is 5 cross 5, and we're using 3 cross 3 filter. I think I showed you one formula yesterday, right? Do you remember the formula? Do you remember the formula, guys? So this was the formula, I think you remember. So the formula was n minus f. So here n is the image size, f is the filter size. Okay, plus 1, then n minus f plus 1. Okay, I think you remember this one, this formula. Yeah, so if you put the value, you'll see that if you are using 5 cross 5 image and if you're applying 3 cross 3 filter, your feature map would be 3 cross 3. Okay, your feature map would be 3 cross 3. So let me show you another demo. So let's say this is the demo. Here we're applying 3 cross 3 filters. Okay, on top of this 5 cross 5 input image, and the feature map we are getting, it's 3 cross 3. Okay, it is 3 cross 3 at the end. So let me take a screenshot and let me move it to my board. Hmm. So let's say this is our demo. So here we are applying 3 cross 3 filters on top of 5 cross 5 input image, and the feature map we are getting, it is also 3 cross 3. Now one thing maybe you have observed, here our input image dimension is getting decreased right at the end, because the original image dimension was 5 cross 5. So after doing the feature extraction, the image become 3 cross 3. Now if I again pass this image to another convolutional layer, so what will happen? Again it will go down, guys, yes or no? Again my image dimension will decrease. So it would be like small, yes or no? Tell me. So I'm getting some question. This look informational. Thank you. It was just working on this kinds of stuff. Can you go into the micro verse? Yeah, definitely. I love your video, sir. Please make on YOLO from scratch, explain how it works and loss functions and everything. Definitely, we'll try to discuss each and everything, okay, in this particular playlist. Theory as well as practical, okay, everything I'll try to clarify. And that's why all the sessions are important, guys, okay, all the sessions are important. So if you see, all of my sessions are interconnected with another one, okay. So if you're joining for the first time, I will suggest you first of all go through my previous lecture, okay, previous like videos in this series. Yep. So guys, I think here you are getting, so after doing this kinds of convolution operation, okay, here we are losing our sorry, here our image is getting decreased. Now image is getting small. Let's say the original image was 5 cross 5. After doing the convolution operation with 3 cross 3 filters, the image has become 3 cross 3. That means here we lose some pixels, yes or no? Okay, here we lose some pixels, right? Hmm. Okay, yeah. So see, now again if I pass this image to another convolutional layer, okay, again if I pass this to another convolutional layer, what will happen? Again I will lose the information. Sorry, not lose the information, that means my image will be small. And if my image is small, that means their convolution operation won't be happening in a perfect way, right? So that's why what we can do, guys, we can use something called padding. Okay, we can use, there is a concept called padding. That means here what I want to achieve, I want to achieve, after doing the convolution, my image size will remain same. Okay, after doing the convolution, my image size will remain same. That thing I want. Let's say if my image size is 5 cross 5, if my image size is 5 cross 5, after doing the convolution, my feature map, that means my resulted image also should be 5 cross 5. This is what I want at the end, right? So how it is possible? Okay, how it is possible? Let's try to understand. See, for this we'll be using something called padding. Now how padding works, let's try to discuss. So here what I will do, I'll try to take this image. Only I'll take this image, I think that would be fine. See, in padding we just try to add some more pixels. How? Like that. Okay, here we are adding something called zero padding. Okay, zero padding. zero padding. That means here we'll have the zero value. Zero value. Then zero means it's a black color. Okay, it's a black color. Now, if I again do the convolution, let's say I am having 3x3 filter. Three cross three filter. Okay, so here I'm having some number. Let's say I can mimic this filter 1 1 1 0 0 0 minus 1 minus 1 minus 1. Okay. Now see, if you do the convolution operations on top of that, guys, now what would be the feature map size, guys? Tell me. What would be the feature map dimension? Let's say this is my 1 2 3 4 5 6 7 1 2. So here I can count. See, 1 2 3 4 5 6 7 1 2 3 4 5 6 7. That means now this image has become 7 cross 7, and my filter I'm using 3 cross 3. Now after doing the convolution, guys, what would be my feature map? Tell me. What would be my feature map, guys? What would be the size of the feature map? Tell me. It would be 5 cross 5. Yes or no? It would be 5 cross 5. Now I think you can see your original. Okay, your original. No, it won't be 4. It would be 5 cross 5 because there is a formula I told you, right? Yeah. Now I think you can see that your original image dimension will remain same. That means original image was 5 cross 5. On top of that, we have added some padding. Okay, we have added some zero padding. Okay, and we are using 3 cross 3 filters, and we saw that our resulted image would be also 5 cross 5. Now here we are not losing the informations. Here we are not losing the pixels. That means my image is not getting downgraded. Got it? And again, see, what is the use of the filters? Because see, whenever you do the convolution operation, what happens? See, this corner value will only appear one time. See, and the middle value, see, whatever multiplication is happening now, it is getting 2 to 3 times. See, the corner value, it is only getting one time for the multiplication, but the middle value, it is getting multiple time multiplied. Multiple time it is getting multiplied. I think this thing you have observed. If you just see it slowly, now I will try to understand what is happening here. The corner value is coming only one time in the multiplication, but if you see the middle value, it is coming multiple time. That means it is trying to more focus on the middle pixels. That means whatever information you have in the middle position, it will try to get more information from here, and all the corner information it will lose. Okay, so this is the another reason we try to add the paddings. Now see, after adding the paddings, what is happening? Now it is trying to focus. It is trying to focus this particular numbers also. See, multiple time this particular number is getting multiplied right now. See, we have added the zero paddings. Now see, multiples time this number is also getting multiplied. This corner value also. Clear? Tell me. So these are some like advantage to use the padding in our CNN architecture. One is we are losing that means our image is getting downgraded. That means our image pixels is getting smaller. Okay, after doing the convolution. That's why we are adding the padding. Okay, that's why we are adding the padding, zero padding. And after adding the zero padding, what we saw? After adding the zero padding, we are getting the same dimension of the image, that dimension we had in the input. So here you can see the visual representation. See, here I have added the zero padding. Now after doing the convolution also, still my feature map would be 5 cross 5. Okay, and the second benefit you will be getting, see, the corner value, it is only coming one time during the multiplication, during the convolution. Okay, if I'm not using padding, and after using the padding, this number is getting multiplied multiple time during the convolution. That means it is extracting the features from everywhere right now, from the corner itself, from the middle position also. That is the advantage. I hope this part is clear, guys. Yep. Now if you're using padding, guys, what would be the formula? So let me write down the formula. So see, the first formula was like that. It was n minus f plus 1. Okay. Now if I'm using padding, so the formula will become like that, n plus 2p. 2p means it's a padding. Okay, padding. Then f plus 1. Okay. Now let's say if I'm having 5 cross 5 image, 5 cross 5 image, and if I'm using 3 cross 3 filters, now what is the output I will be getting? Just try to put the number. So let's say n, it's 5, then 2 multiply by 1 padding, because I'm using one padding only, because you can see only one padding, and you have to use only one padding. Okay, not multiple padding, guys. Okay, only one padding. That means one row. Everywhere we will try to add one row. That's why we call it as a one padding, and we also call it as a zero padding. So that's why it's 1. Now minus f, that means 3, filter size is 3, and plus 1. Okay, now if you calculate the number, it would be 7. Okay, it would be 7 minus 3 plus 1, and it will become 5. Okay, it will become 5. That means this is the output dimension of your feature map, and this will become your original image right now. See, got it? So this is the formula, always remember. Yeah, now Shofik is telling now I am clear about padding. Yeah, thank you. Hmm. Now see, whenever you will be doing with the help of code, let's say we'll try to implement with the code, and we'll be using something called TensorFlow, Keras. So in Keras, uh, if we add the padding, we call it as a valid. No, so not valid, it would be same. Okay, and if I'm not using padding, it would be valid. Okay, same means you are adding the padding, and valid means you are not adding the padding. Okay, in Keras, whenever we'll try to develop with the code, that time. So let me show you one implementation. So let's open up our Google Colab. See, I'm telling, whenever you will be implementing with Python, let's say you will be using something called TensorFlow package, because TensorFlow is a deep learning package, right? So there, what happens? If you want to add the padding, let's say if you want to add this zero padding, you have to specify same. Padding is equal to same. Okay. And if you don't want to specify padding, you have to specify padding is equal to valid. Got it? So let me show you the implementation. That would be clear. I'll show you the padding demo, practical demo. And all of us, please hit the like. If you are liking the session, please hit the like, guys. So here I can write padding and stride demo in CNN. So let's connect the notebook. But before connecting, so here we're using neural network. So let's select our GPU machine. So change runtime type. We'll be using T4 GPU. Okay. So see, I'm using Colab because I know that there are some people they doesn't have the GPU integration in their system. That's why I'm using Google Colab. Okay. Because in Google Colab, you'll be getting one free GPU called T4. Now let me connect that GPU. So after connecting, let's import some library. So the first library I'm going to import Keras from TensorFlow. So from TensorFlow, and TensorFlow, it is already installed in Google Colab. Okay, you don't need to install it separately. Import Keras. Then I need some layer. Okay, I need some layer. That means the convolutional layer, and is available in the keras.layers. Okay, keras.layers. Layers, import. I need dense layer first of all. Okay, why dense layer? Because I think I showed you the CNN architecture. CNN architecture. So I think you remember. So let's take this architecture. See, in CNN architecture, what you have the convolutional layer. Okay, and you have the pooling layer. But as of now, I'm not going to introduce the pooling because I haven't explained the pooling. Okay, without pooling, I'll try to create the network. So convolutional layer I need, and I also need the ANN. That means fully connected layer. Okay, artificial neural network. See, if you combine CNN and ANN, it will become a convolutional neural network. Okay, so at the end you have to also use artificial neural network. Okay, so for this we are importing the dense. So those who have already worked with deep learning, I think you know. Okay, we call it as a dense layer. Then I need convolution layer. So in Keras, the convolution layer is nothing but con2D. Okay, con2D. Okay, you can call it as a con2D. This is called actually convolutional layer. That means this layer, this convolutional layer, 2D, and this is the dense layer. Then you also need something called flatten layer. Okay, why flatten? Because at the end, see what you are doing here. See, after extracting the features, okay, after extracting the features, all of the feature map you are getting, you are doing the flatten operation. You can see that's why flatten layer is required. So that's why we are importing also flatten layer. Okay, before passing it to the dense layer. And this would be a sequential architecture because first of all, CNN architecture would be there. That means convolutional layer. Okay, then your fully connected layer. Okay, that means dense layer. So it's a sequential architecture. So for this, we also need to import sequential from the keras. So from keras, import sequential. Okay, then I need a data. So I'm going to use this MNIST handwritten data as of now, just to show you. Later on, we'll try to use the custom data. We'll try to export different data. MNIST handwritten data set. So see, this is the data set we'll be using. So this is the handwritten digit data, guys. Okay, so you have to recognize the digit. But here I'm not doing any kinds of classification, just to show you. Okay, just to create the architecture. Or see, as of now, I'm not going to use any data. I think that would be fine because I will only create the architecture, because later on I'll show you how we can use the data. So let's, ignore the data as of now. Data I'm not going to use. Okay, so now let me import all of them. Yeah, it has executed successfully. Let me execute it. There is no error. So now let's build one CNN network. Okay, let's build one CNN network right now. So first of all, you have to make the sequential layer. So model is equal to sequential. Model is equal to sequential. Okay, now you can add multiple layer, because now it will become one sequential layer. Sequence, you can add the layer sequentially. So let's say after you will be adding convolutional layer. Okay, and multiple convolution layer you can add. And after that you will be doing the adding the flatten layer, then you'll be adding the dense layer. That means your fully connected layer. Okay, so that's why we have created a sequential object at the very first time. Now we'll try to add the CNN let's say layer. Okay, that is convolutional layer. For this, just write model.add. Okay, model.add. Inside I'm going to add my convolutional layer. That means conv2d. Okay, and conv2d takes some parameter. So the first parameter it takes, guys, the filters, a number of filters you want to use. So I think you already know what is filters. Filter is nothing but it's a feature extractor. It's a kernel, right? Now I think I showed you in my previous let's say video, I can use multiple filter, guys. Let's say here I have a dog. I have a dog image. Let's say I can copy a dog image. This is my dog image. And now if I want to extract the feature from this particular dog image, I need multiple filters. Let's say this is filter 1, this is filter 2, this is filter 3, this is filter 4, and so on. Okay, F1, F2, F3, F4, and so on. Now one of the filter will try to extract the eye, another filter will try to extract the nose, another filter will try to extract the ear, another filter will try to extract the tail. Okay, so every filter has different kinds of sensing power, because I already compared now with our visual cortex also. They are having it is having actually different cells, and all the cells is having different kinds of sensing power. Some of them will try to recognize the vertical line, some of them will try to recognize horizontal line, some of them will try to recognize the this kinds of flattened line. Okay, so that's why here we have to always use multiple filters to extract the features from the image. Okay, not only one filter. So now you can use as many as filter you can. So as of now I'm going to use, let's say I'm going to use 32 filters. I'm going to use here 32 filters. That means let's say if this is your input image, here you are using 32 filters, 1 2 3 dot 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 34 filters you are applying on top of the image to extract the features. Okay, now how many feature map I will be getting, guys, after applying the 32 filters? I'll be also getting 34 feature map. Sorry, 32. It is 32 now. So 32 feature map I'll be getting. Got it? So let's use 32 filters for this demo. Now here you have to specify, okay, now you have to specify the filter size. So filter size you have to write like that, kernel size. It should be kernel size, okay, kernel size. Now here I'm going to take 3 cross 3 filters. That means these kinds of filters I'm taking 3 cross 3, and this particular filter value would be randomly initialized at the very first time. So whenever we'll do the model training, that time it will try to adjust during the back propagations. Okay, now let's say if I want to use the padding, okay, now if I want to use the padding concept, so I think here is the padding. If I want to use the padding concept, that means if I want to, because what is my input size? What is the MNIST input size, guys? Tell me. MNIST handwritten digit, if you see, MNIST handwritten digit dimension. It's 28 cross 28, I think. Not this one. Yeah, so you can see it's 28 cross 28. Open image in a new tab. See, all the pixel, if you count, it's 28 cross 28 dimensional. Okay, 28 cross 28 dimensional image. Okay, so now if I want to get the same size, okay, after doing the convolution, that means here I showed you, if I want to get the same size after doing the convolution, what I have to do, I have to add the zero padding. Okay, and if I want to add the zero padding in Keras, you have to write like that. So you just give comma and just write padding is equal to valid. No, I think padding not is equal to valid. It would be same. Yeah, that means you are using padding, because here I have written down, I think same means you are using padding, and valid means not using padding, not padding. I think it makes sense, guys. Sir, after CV playlist, which playlist will come? Let's see, Saurabh. Let's first of all complete the CV playlist, then I'll let you know. I also need the public, let's say, opinion. Based on the public demand, we'll try to bring the playlist here, okay? So padding is equal to same. That means we are adding the zero padding here. Okay, zero padding we are using. And here you have to use the activation function. Okay, activation function. So activation is equal to, I'm going to use ReLU. So if you see everywhere in CNN network, people use ReLU activation function. Okay, but in the old architecture, people used to use any other activation function like, let's say, softmax, sigmoid. Okay, these are the activation function people used to use. But nowadays, ReLU has been used. Because why? Because I think I showed you one demo yesterday. So I think you remember. See, in the day 4 deep lizard.com website. So let's say if I do the convolution operation here. So let's say I want to do left edge filter. I want to only get the left edge. Okay. Now if I run that, so this is the results I'm getting, and the left edge is nothing but your red one. So this red color is nothing but your left edge, and whatever blue you can see, this is the right edge. Okay, and this is a negative value. Okay, this is a negative value. This is a negative number. So to remove this negative number, we use ReLU activation function. That means what ReLU does? What ReLU does? Let's say if any number is negative, so what it will do? It will try to make it as 0. Okay, and if any number is positive, let's say any number is like that, let's say 0.25, so it will make it as 1. Okay, so that's how ReLU works. That means wherever you have this particular blue mark, that means it's a negative number, it would be 0. That means this particular edge would be disappear automatically, because I only need the left edge, not the right edge. So only left edge would be available that time. Okay, if we apply the ReLU activation function on top of that. Okay, so that's why we use ReLU activation function in convolutional neural network. Got it? Yeah. Then you have to specify the input size. Okay, the input size, that means what would be the image input size. So here let's say we are using MNIST dataset. Okay, MNIST handwritten digit dataset. So let's import the MNIST here, and that's how we can load the data. Okay, mnist.load data, you'll be getting xtrend, ytrend, xtest, ytest. Okay, and if you see the shape, let's say I want to see the x underscore trend dot shape, you'll see that 28 cross 28. Okay, and how many examples you are having? 60,000 images you are having. Okay, for the training. So here input size would be input shape. Okay, input shape would be 28 comma 28 comma 1, because it's a grayscale image. Okay, it's a grayscale image and it is only having one channel. Okay, here you have to specify the channel also. You can't skip. Okay, here you have to specify the channel, and if you're using color image, that time you have to use 3. Okay, so this is your first layer. This will become your first layer. Now I can also add multiple layer. I can also add multiple convolutional layer, guys. Multiple convolution. Let's say this is the convolution. Now let's say I want to add another convolution. I can also do it. So what I will do, let me show you another convolution. This is another convolution. Model.add conv2d. Okay, again I'm using 32 filters, and the filter size is 3 cross 3. Padding is equal to same, because I'll be using padding, and activation is equal to ReLU. And now you don't need to pass the input shape, because input shape would be only passed at the first layer, not in the hidden layer. Okay, now if you want, I can also add another convolutional layer. I can add another convolutional layer. Okay, and here I'm also using 32 filters. You can also use, there's a 28 filters. It is also fine. Okay, if you're using 28 filter, it is also fine. This is completely a hyperparameter number. Okay, because here we are getting our custom architecture, and this kinds of kernel size, I can give anything. Okay, and make sure whenever you are giving the kernel size, it would be odd number, not the even number. Okay, you can use 3 cross 3, 5 cross 5, 7 cross 7. Okay, like that. But most of the kernel, you will see that people will be using 3 cross 3 and 5 cross 5. Okay, and this filter, number of filter, you can give anything. The more filter you will be giving, the more information it will try to extract. Okay, based on the image complexity. Let's say if your image is having like very very complex, that time you can increase the kernel size. Number of filters. Okay, yeah. Now once it is done, what I have to do, I have to use the flatten layer. As of now, I'm skipping the pooling layer, guys. Okay, because pooling layer I haven't explained, that's why I'm skipping the pooling layer. Now let's add the flatten layer. So how to add the flatten? Model.add flatten. Okay, model.add flatten. So here we have already imported the flatten. Okay, now we can add the dense layer, that means FC layer. Now I think you remember how we can add the FC layer. So that's how we can add the FC layer. Model.add dense layer, and this is the number of units, that means number of neurons we are using. Okay, and activation I'm using ReLU, and here at the last layer, I'm using only 10 units, because if you see MNIST handwritten digit, it is having 10 digit, 0 to 9, 0 to 9. Okay, that means if you count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, you are having 10 digit. Okay, 10 digit, that's why output would be 10, and multiple output, that's why we are using softmax activation function. Okay, now let's make the architecture. So here it is giving me one error, activation. I think activation spelling is correct. Unexpected keyword activation. Let me execute it. Okay, so I'm getting an error, guys. Let me check. Okay, now it is working because of this bracket. Okay, I've given inside that. Now if I show you my model.summary, model.summary, so this is the entire architecture. Now one thing you just observe. Okay, one thing you just observe. Okay, here I'm using same. Why it would be sorry, it would be same everywhere, not valid. Yeah, now let me execute. Now we get the model summary. Yeah, now guys, one thing I think you can see, this is my original image at the first layer, 28 cross 28. Okay, and I'm using 32 filters. Then after doing the first convolution, again my image size remains same, 28 cross 28. After doing another convolution, again my image size remains same, 28 cross 28. Okay, then flatten, then dense. How? Because here we are using zero padding everywhere. Clear? Tell me how to implement with the help of code. Clear, all of you? Yes. Right? Okay, now let's say if I don't want to use the padding, that time what I will do. So this is my padding demo. Okay, so here you can consider, can comment model, or let's say I can write with padding and without padding. So here you have to give the valid if you don't want to use the padding. Okay, now if I create the architecture, now if I show you the summary, so see, now I'm not using padding. So at the first convolutional layer, it was 28 cross 28, and I'm using 3 cross 3 filters. Okay, so that's why it will become 26 cross 26. Then in the second convolution, again it will become 24 24. Then the third convolutional layer, it will become 22 22. Okay, I hope you got it. That means now it is working like that. You are not using any padding. So far guys, clear? Let me know how many of you are clear. Just write clear in the chat. If you clear guys, so please write clear in the chat. And please hit the like guys, all of you hit the like. If you're liking the session, hit the like. And if you're new to my channel, please try to subscribe. Okay. So now let's discuss the next topic called stride in CNN. Why stride is important, okay, and why we have to use it. Let's try to understand. See, first of all, let's try to understand what is stride. So for this, I'm going to take an image. I think I have some image inside my folder. Image I can take. This one. So maybe I can take this one. Let's copy, paste it here. Okay, I'm not getting any number. Let me take the screenshot. So see, what is stride? First of all, let's try to understand. See, what I told you, stride is nothing but it's a movement on the image grid. Okay, let's say this is your kernel. This is your filter 3x3. So first of all, what will happen? You will try to plot this filter on the image like that. Okay, that's how your convolution will start. This is the first step, and what it will do, it will do the number wise multiplication. So once it is done, okay, it will create the feature map here. Then it will move to the next one. That means here, next grid. Okay, so once this is done, again it will move to the next grid here. So this movement you are doing now, this movement, it is called stride. Okay, this is called stride. And what is the stride parameter? It's 1, because here we are only moving the one grid. Okay, then again what will happen? It will go down. That means here. Okay, one grid down. You can see one grid down. Okay, then again it will start from here. Again start from here. Again start from here. That means stride is equal to 1. Okay, and this is called stride. And if you see visually, so this is the visualization of stride. See, this is the visualization of stride. It is moving to the entire image. Okay, now stride parameter you can also change. Let's say if I'm changing to 2, stride is equal to 2. Stride is equal to 2. Now how many grid it will skip, guys? It will skip one grid like that. So first of all, let's say this is your filter. Now in the second iteration, it will skip this particular pixel, this particular grid. Then it will again start from here. It will start from here. Okay, that's how. Now in the next one, that means in the next row, it will skip this particular grid. Then it will start from here. It will start from here. Okay, then again it will skip. It will start from here. So this is called stride is equal to 2. Stride is equal to 3 means it will skip two grid. It will skip 2 grid. That means it will start from here. But again you can see, if it is a 3x3, so here you can't match 3x3. Okay, you have to add some paddings at the end. Okay, so this is called actually stride. So with the help of stride, your kernel, your filters will try to move through the entire image. Okay, entire image. Now one issue you will try to see here. Let's say if your stride is equal to 1, that time it is fine. Okay, if stride is equal to 1, that time it is fine. That means it is not skipping any kinds of grid. But if you are taking stride is equal to 2, stride is equal to 2, that means what is happening? It is skipping. Let me draw it. It is skipping one grid. Let's say from here it is starting. So can you see some information getting lost here? Okay, you are also losing some information. So if your stride size is equal to more than 1, that means you are losing some information at the end. Okay. And when you use stride is equal to 2, that means more than 1. So whenever you only need high level feature, that time, let's say you don't need the low level feature, only high level feature, that time you can skip the part. Okay, so let's say if I'm talking about this dog example now, so let's say if I start from here and if I get the ear, eye, nose, this tail. Okay, so if I get these are the information, at least I can consider this is a dog. This is a dog, right? So I don't need to extract the entire information from the image. So that time you can increase the stride size. If you want to lose some information, you can increase the stride size that time. Okay, and increasing the stride size, you will be getting two benefits. One is the fast computation, and one is another is I think this one, less time. Okay, less time, that means it will take less time to train the model. Okay, and if you are not taking stride is equal to more than 1, that means what will happen? It will take like more time to do the convolution operation, because it will go through the entire grid of the image. Got it? And another thing, if you are using stride, okay, stride is equal to 2, that means more than 1, again you will lose some again you will lose what? You will lose the image information. Let's say this is the formula, guys, you have to remember. So if you are using stride, so this is the formula, n minus f divided by s is nothing but stride, then plus 1. Okay, this is the formula. Now what will happen? Let's say you are having an image. Let's say you are having 5 cross 5 image, and you are using 3 cross 3 filters. Now if you put the number, let's say image size is equal to 5, f, that means filter is equal to 3, stride, let's say you are using stride, you are using, let's say 2, so stride is equal to 2 plus 1. Okay, now if you just do the calculation, it would be 2 by 2. Okay, it would be 1. Okay, now what would be the answer, guys? It would be 1 plus 1 plus 2. Now you can see your resulted image would be 2 cross 2. 2 cross 2. That means you are losing very high level information here. Like you can see the image dimension was 5 cross 5, and if you are using stride is equal to 2, resulted image would be 2 cross 2. That means it is getting decreased at the end. You are losing so many information from the image. Clear? I hope it is clear to all of you. Now I'll show you the code demo. Okay, how in the code I can mention the stride size. We'll try to see that. Okay, yep. So fine, now again you can see the visualization, how stride works. You can see, so this is the stride operation happening. Now it is skipping one grid, you can see. So it is they are using stride is equal to 2 here. Okay, see, So let me show you the code example. So see the same code you can copy. So here I can comment stride. Only here there is a parameter you have to pass here called stride. So stride, okay, stride is equal to 2 comma 2. 2 comma 2 means you are using stride is equal to 2. Okay, in Keras you have to write like that, 2 cross 2. And if you are not giving the stride, that means it will take the default stride, that means 1. Okay, it will not skip any kinds of grid. Now I can mention in the all the let's say layer, like that I can mention in all the layer. You can see 2 cross 2, 2 cross 2, 2 cross 2. Okay, now see what would be the feature loss. Now if I execute, now if I show you the model summary, so see guys, your original image size was 28 cross 28, and after adding the stride is equal to 2, 2 cross 2, see this is the loss of the image. Now it become 14 cross 14. Now after doing another convolution, it becomes 7 cross 7. That means half of the, okay, half of the pixel is getting degraded. Okay, half of the pixel you are losing. Then it is 4 cross 4. Then you are doing the flatten operation. That means here you are losing so many information, but you are getting some high level feature at the end. Okay, this is the idea. So always try to use stride is equal to 1 guys. Okay, not 2. If you are creating your custom architecture that time, and going forward we'll be using like pre-trained model transfer learning approach, so that they have already defined their architecture size. We don't need to worry about. We'll just try to download. On top of that, we'll try to train our model. Okay, that's it. Yes, this is the concept. So yes, this is the easiest explanation guys I can give on top of the padding and stride. Now in the next class, we'll try to understand one very important topic called pooling layer. Pooling layer in CNN. CNN, okay? Hmm. So after pooling layer, we'll start discussing the architecture, different architecture. And we'll also move to the practical part. So we'll take the image and we'll try to build the project on top of that. So I have guys, you understood the entire session regarding the padding and stride. Now all the resources I'm going to share in the GitHub. From there you can, so let me share it. Let me export it. Export to PDF. Today is day 5, right? Day 5. And I also have one notebook. This code notebook I'll also try to share with you. Where is my folder? It is day 5. YouTube day 5, this one. Now I'll try to push the changes. Now if you go here and if you refresh, so see day 5 would be available. Okay. Yeah. So yes, guys, this was our padding and stride in CNN. Now let's connect in the next class, and we'll try to understand the pooling. Okay, pooling layer inside CNN. So this was the basic, guys. This was the theory, and unless and until you are not understanding the theory, you are not sure with the theory, so definitely you will be getting some difficulty, okay, to understand the entire architecture. So that's why I have clarified these are the basics and foundation things, so that later on I can show the practical in a easiest way. Okay. So how was the session, guys? How was the session? Did you like the session? Okay, so Abhinandan Das is telling use fan. I am running on backlog, not able to follow on live. Great job, Bapida. Thank you so much. Thank you so much, Abhinandan. Rahul, thank you. Thank you, guys. So I just need your support, guys. Please try to support my channel. So let's try to hit 50k subscriber as soon as possible. Okay. So let's hit 50k subscriber, and let's came up with some amazing, let's say, playlist on my YouTube channel. Okay. Thank you, guys. And this is my promise, guys. I'll always focus on the quality content. Okay. Because quality is the main priority I give. So quality should be there in my content. Okay. Whatever content you will be getting. Yep. Okay, guys. So thank you, guys, for joining. So let's connect in the next class with our next new topic. Bye, everyone. Good night. Thank you, guys. Bye. And please hit the like, all of you. Hit the like. I can see like many people are watching, but only some few likes I can see. So hit the like, guys, all of you. And please subscribe. Okay. If you're new, please try to subscribe. And if you are watching the live, guys, entire live, so maybe you are getting the topic with the timestamp. You can also comment the timestamp in the comment section. So I will add the timestamp in the description. Okay, so that you can also see the timestamp, like let's say in which time I covered which topic, right? So those were like following the entire live. So maybe you can take the timestamp and you can share me in the comment section. So from there I'll try to pick up and I'll add in the description section. Yeah. So let's learn together, guys. Thank you, guys. Bye, everyone. Good night. Thank you.